What would happen if Earth's gravity suddenly became 10% stronger? At first, the change might not sound especially frightening. Most people imagine feeling slightly heavier, while life continues much as it did before. A commuter stepping onto a train in London notices nothing unusual at first, while a family preparing breakfast in Toronto continues its morning routine. Across airports, highways, schools, and offices, daily life appears normal. The planet looks unchanged, and the sky offers no obvious warning. Meanwhile, scientists monitoring Earth's physical systems begin detecting a strange anomaly. Instruments indicate that gravity is exerting a stronger pull than expected. Some assume humanity would simply adapt, because humanity always adapts. Muscles work harder, movements slow slightly, and the world carries on under a slightly heavier burden. But that's not even the most dangerous part, because gravity does far more than keep our feet on the ground. It quietly influences every movement, structure, atmosphere, ocean, and living thing on Earth. The first effects would appear inside the human body. A 10% increase in gravity means every person, animal, and object on Earth suddenly weighs 10% more than before. A teacher climbing stairs in Manchester reaches the top slightly more breathless than usual. A delivery driver in Chicago notices that carrying packages requires more effort throughout the day. At first, the difference feels manageable. Most healthy people continue working, exercising, traveling, and following routines with only minor adjustments. In hospitals and research centers, scientists begin studying how stronger gravity affects muscles, joints, circulation, and the body's demand for energy. Meanwhile, engineers review safety margins built into elevators, cranes, aircraft, and structures designed under Earth's previous gravitational conditions. Government agencies quietly gather data, while experts attempt to understand whether the change is temporary or permanent. The planet still looks familiar, but billions of lives are now operating under a force that has silently become stronger. Within days, the effects begin extending beyond people. Gravity is not only pulling harder on living things, it is pulling harder on everything. Cargo aircraft require more lift to stay airborne. Airlines begin noticing higher fuel consumption as planes work harder to carry the same passengers and cargo. Across major ports, shipping companies monitor rising transportation costs. Moving goods across oceans remains possible, but every journey now requires more energy than before. Scientists studying the atmosphere discover another concern. The denser pull of gravity begins slightly compressing the lower atmosphere, altering pressure patterns in ways that are not yet fully understood. Meteorologists compare new observations against decades of climate records. The atmosphere still behaves normally, but subtle differences are beginning to appear. Government agencies establish international working groups as experts attempt to predict what stronger gravity could mean for transportation, weather, and infrastructure. The change is no longer affecting individuals alone. It is beginning to influence the systems that keep civilization moving. Weeks pass, and the strain begins appearing in places that were never designed for a stronger world. Most structures remain safe, but the margin between normal operation and failure starts becoming smaller. Engineers inspect bridges, towers, cranes, and transportation systems that now carry 10% more effective weight than before. The change sounds small, yet it affects billions of daily operations. In construction sites across multiple countries, workers notice machinery consuming more fuel while lifting the same materials they handled only weeks earlier. Scientists monitoring Earth's oceans discover another consequence. Stronger gravity slightly alters how water distributes itself across the planet, producing subtle changes that ripple through tides and coastal systems. Meanwhile, power providers report increasing demand. Heavier transportation, harder working machinery, and greater physical effort all require additional energy. Governments begin updating infrastructure guidelines, while emergency planners review systems that were designed for a different gravitational reality. Humanity is still adapting, but the cost of maintaining modern civilization is steadily rising. By the second month, the effects begin reaching places most people never associate with gravity. The force pulling everything downward is also influencing the air above their heads. Meteorologists studying global weather patterns notice storms behaving differently. Some weather systems become more compact, while others struggle to develop in ways scientists would normally expect. A commercial pilot flying across the Atlantic receives updated performance guidance as aviation authorities adjust procedures for the heavier atmosphere and aircraft operating conditions. Across mountain regions, climbers, hikers, and remote communities experience subtle changes in air pressure that researchers are still working to understand. Meanwhile, ecologists begin tracking unusual responses in wildlife. Animals that evolved under Earth's previous gravity now expend more energy moving, hunting, migrating, and surviving. Government agencies expand monitoring programs, while international scientific teams exchange data around the clock. The anomaly is no longer affecting isolated systems. It is beginning to reshape how Earth's atmosphere, ecosystems, and transportation networks interact with one another. By the third month, scientists reach a troubling conclusion. Earth's gravity is not returning to normal, and many of the effects are beginning to reinforce one another. And this is where the scenario becomes especially unsettling. What began as a physical change is now becoming a systems problem. Transportation requires more energy. Infrastructure requires more maintenance. Ecosystems require more effort to sustain. In major cities, utility providers struggle to balance rising demand against systems that were never designed for a permanently heavier planet. Across farms, forests, rivers, and coastlines, small stresses accumulate into larger pressures. No single change is catastrophic, yet together they are steadily reshaping the world. Government agencies shift from monitoring to adaptation. Long-term plans are developed for infrastructure, food production, transportation, and energy systems, expected to operate under stronger gravity for years to come. Humanity is no longer waiting for the anomaly to end. It is beginning to redesign civilization around it. Years begin to pass, and a generation grows up knowing only a world with stronger gravity. For them, the anomaly is no longer unusual. It is simply part of life. Children learn to navigate a heavier planet, while athletes, workers, pilots, and engineers adapt to physical limits that previous generations never experienced. Scientists continue studying the long-term consequences. Some ecosystems stabilize under the new conditions, while others gradually transform into something different. Around the world, nations invest heavily in redesigned transportation systems, stronger infrastructure, and technologies capable of operating more efficiently under increased gravitational stress. Yet every solution carries a cost. More energy is required, more resources are consumed, more effort is needed to accomplish tasks that once seemed routine. And perhaps that is the most unsettling realization of all. The challenge was never surviving stronger gravity. Humanity proved it could do that. The challenge was discovering how many hidden systems quietly depended on gravity, remaining exactly as it was. A force so familiar that most people never noticed it had become one of the foundations of civilization itself. Earth would survive the change. Oceans would still move across the planet, cities would still function, and daily life would continue adapting. The atmosphere would remain overhead, while future generations grow up accepting stronger gravity as an ordinary part of existence. Scientists would continue studying long-term consequences, searching for new patterns across ecosystems, whether systems, oceans, and the living world. Governments and public agencies would spend decades improving infrastructure, transportation, energy networks, and services designed for a heavier planet. Businesses, workers, families, and communities would gradually build new routines around conditions that once seemed almost unimaginable. But perhaps the deeper lesson is not about gravity itself. It is about how easily humanity overlooks the systems supporting everyday life. If you enjoyed this journey into the quiet systems that shape our round, blue world, please like, share, and subscribe to the channel. How do you plan to adapt if gravity became 10% stronger today? Let us know in the comments. Thank you for watching. Stay curious.